So now we are going to learn about cube roots of unity. So whenever we have an equation like this, x squared is equal to 1, then we say that x is equal to plus or minus 1. Okay, x can be either 1 or minus 1. But when we have x cube is equal to 1, when we have an equation like x cube is equal to 1, we simply say x is equal to plus 1, isn't it? But when we have two values of x for this equation, we suspect that there may be three values of x for this kind of cubic equation. But still, we always say x is equal to plus 1. So, are there any other values of x for which this equation is true? Of course, there are two more values, not in the real world, but in the complex world. Okay. See, in complex number system, we have an assumption, that is I square is equal to minus 1, isn't it? So, based on this fact, I square is equal to minus 1, we are able to get the two more values of x for this equation to be true. Okay. So let us consider the equation x cube is equal to 1. So now we are going to find the values of x for which this equation is true, isn't it? So now let me, in the next step, what I am going to do is take this 1 to the left hand side. I'll be getting like this. Okay, so this 1 can be considered as 1 cube. Okay, so now this is time to recall the formula for a cube minus b cube, which equals a minus b times a square plus ab plus b square. Okay, so if we use this equation here, then we get x minus, if we use this identity here, we get x minus 1 into x square plus x plus 1 square, which is 1, equals 0. So there are two factors, the product of them is 0. So we can understand that either x minus 1 is equal to 0 or x square plus x plus 1 is equal to 0. So if x minus 1 is equal to 0, then x must be equal to 1. And on the other hand, we need the formula for solving this quadratic equation. So the quadratic formula, let us recall, x is equal to minus b plus or minus root of b square minus 4ac by 2a, right? So using this formula for this equation for finding the value of x, so we have this is a, which is 1, b, which is again 1, c is also 1, right? Okay, so let us substitute in the formula minus 1 plus or minus root of minus 1 square minus, this is plus 1 square. So 1 square minus 4 into 1 into 1 by 2 into 1. So we have minus 1 plus or minus, this is 1 minus 4, which is minus 3, square root of minus 3 by 2. See, we have I square is equal to minus 1. So I is equal to square root of minus 1, isn't it? So this is going to be, this minus 3 can be written as 3 into minus 1. So square root of minus 1 into square root of 3. So we can write root 3 into I divided by 2. So therefore, the value of x for which this equation is true, or 3, there are totally 3 values. Okay. So therefore, we can say that we can call them as cube roots of 1. Okay. Cube roots of unity means cube root of 1 are 1 and these two values, minus 1 plus root 3i by 2 and minus 1 minus root 3i by 2. Okay. So these two complex numbers are actually conjugate to each other. Okay. See here plus and here minus, that's the only difference. And now for convenience, we can name this as omega, the Greek letter omega, and we can name this as omega square. So you may be wondering, if it is omega, should it be omega square? Of course it is. Let us check it out. See, we assumed that omega is equal to minus 1 plus root 3i by 2. So when we square this, will it become omega square? The next one, let us see. So will it become the next cube root of unity? Let us check it out. So omega square is equal to, let us find out, minus 1 plus root 3I by 2 the whole squared. So which is, okay, here we, let us apply the identity for a plus b whole square. So a square plus 2ab plus b square, right? And in the denominator 2 square, okay? So minus 1 square is plus 1, then this is minus 2 root 3I. This is root 3 square is 3, but I square is minus 1. So we can write it as minus 3 by 2 square is 4. 1 minus 3 is nothing but minus 2 root 3 by 4. Taking 2 common outside and cancelling with the 4, we get remaining, we get minus 1 minus root 3I divided by 2. Yes, this is nothing but the remaining, the third cube root of unity, isn't it? And you can try it, try another thing. So when we square this omega square, okay, this one, when we square this again, we will really get back to this omega. Isn't that interesting? So that is because of the fact that, see, when we square this omega square, actually it is equivalent to omega power 4. But we already know that omega cube is 1, isn't it? Because this is cube root of unity. So when we cube it, definitely our answer is going to be 1, isn't it? So again we are getting omega. So when we square omega, we are getting omega square. When we square omega square, we are getting back omega again. Okay, so this is one very interesting property about the cube roots of unity. Okay. Now let us see some more interesting things about cube roots of unity. So I can say one thing like the square of, sorry, already we have the 3 cube roots of unity, 1 omega, omega square. So these are the cube roots of unity. The sum of, okay, the sum of these 3 cube roots of unity is going to be 0. Okay, why? Do you know? Let us see the proof. So 1, let us have it 1 plus omega. Omega is this one, minus 1 plus root 3I by 2. And then we know that omega square is minus 1 minus root 3I by 2. So let us add them together. We will get, let us see. Okay, take LCM. 2 minus 1 plus root 3I. Okay, so here I multiplied and divided by 2, so that I am getting 2 here. Then minus 1 plus root 3I. Then take this plus inside, you get minus 1 minus root 3I. So look at this, root 3I minus root 3I cancel. 2 minus 1 is 1, 1 minus 1 is 0. So 0 by 2 is nothing but 0. So this is very important property about the cube roots of unity. Okay, 1 plus omega square is 0. Okay, so one thing that you have to note is we can consider this as omega, so that will be omega square. On the other hand, you can also consider this as omega, because the square of this is this, so that this can be considered as omega square. So in either way it is correct only, right? And one last thing that I would like to say is the property which goes like the reciprocal of, okay, the reciprocal of one is the other. This is a property that is worth discussing. See, one means one and the other means the omega and the omega square. Those two, the complex cube roots of unity. About them only we are talking again. So if we find the reciprocal of one, we will get the other one, right? See, let us find out. Let us find the reciprocal of omega. So what I am going to do is, let me multiply and divide by omega square. Okay, so if I multiply and divide by the same quantity, the value will not be affected. Everybody knows this, right? So 1 into omega square is omega square. Omega into omega square is omega cube. But omega cube is equal to 1. So omega square by 1, which is equal to omega square. Similarly, if I find the reciprocal of omega square, it is going to be the same procedure. Okay, we have to multiply and divide by omega. So we get omega by omega cube. but omega cube is 1. So answer is omega. So we can say that the reciprocal of one complex cube root of unity is nothing but the other one, right? Okay, I hope you all enjoyed this lesson. See you. Bye. Thank you.